Hi, everybody. It's Professor Mitchell, and I believe we are finishing up Chapter 2 in this video, looking at Section 2.5 on the Gauss-Jordan method for calculating inverses, which is the only thing we'll do in this section. So let me explain how that works. It's kind of magical, actually. To find the inverse of a matrix, especially when the matrix is not 2 by 2, because remember in the last section, we sort of developed a formula for the inverse of a 2 by 2 matrix. So this will work for a 2 by 2, but it will also work for a matrix of any other size. Write down the matrix A, and on its right, write an identity matrix of the same size. Then perform elementary row operations on the left-hand matrix so as to transform it into an identity matrix. These same operations are performed on the right-hand matrix. When the matrix on the left becomes an identity matrix, the matrix on the right is the desired inverse. So for the first example, I thought it would be nice to calculate the inverse of a matrix that we've done before using a different method. And that would be this matrix. In the last section, we found the inverse of this matrix using the formula for the inverse of a 2 by 2 matrix. So now let's find it using the Gauss-Jordan method. So switching over to the tablet. All right, so this is how you start off using this method. Notice that I have adjoined the given matrix with an identity matrix. So now I'm going to start performing row operations on this matrix until the left-hand side looks like this. And then on this side, we will have our inverse matrix. Okay. All right, so I'm going to get rid of that. That was just to show you sort of what the goal is. All right, so now let's start doing it. So remember our elementary row operations. We're going to start by getting a 1 in the top left corner, and we'll do that using elementary row operation number 2. We'll multiply that row by -1/2, and that's going to change row 1 into 1, -2, -1/2, 0. Okay, so the next step is going to be to put a 0 in the spot where that -3 is. And that's using elementary row operation number 3. So we want to change row 2 by adding to it 3 times row 1. So 1, -2, -1/2, 0. All right, and now the new row 2 is going to look like this. -3 plus 3 times 1 is 0. That was the whole point. 7 plus 3 times -2 is 1. 0 plus 3 times -1/2 is -3/2. 1 plus 3 times 0 is 1. All right, so at this point, we're almost done. We lucked out with the 1 in this spot because if I didn't already have a 1 there, I would be using elementary row operation number 2 to get a 1 there. So really the only thing left to do is to get a 0 in this spot. And we're going to do that using elementary row operation number 3. We're going to change row 1 by adding 2 times row 2. All right, and I think what I'm going to do, just to make this a little easier to follow, is I will erase this up here. Okay, so let's talk about the new and improved row 1. All right, so remember we're doing row 1 plus 2 times row 2. So 1 plus 2 times 0 is 1. Negative 2 plus 2 times 1 is 0. That was the whole point. Okay, negative 1/2 plus 2 times negative 3/2. Sometimes they get a little tricky here. So negative 1/2 plus 2 times negative 3/2 is negative 1/2 plus negative 3. Negative 3, let's think of that as negative 6/2. So negative 1/2 plus negative 6/2 is negative 7/2. And then 0 plus 2 times 1 is 2. And we like row 2 just the way it is. And lo and behold, the matrix on the right-hand side of this is the inverse matrix. You can check your notes. That is the same inverse that we got using the formula. So A inverse is still negative 7/2, 2, negative 3/2, 1. All right, going back to the presentation. All right, so for the next example, we will find the inverse of a 3x3 matrix. So we start off the same way. Let's go back to the tablet. It's just going to take a little longer because it's 3x3. So we're going to have to do more elementary row operations. All right, so we're going to start by using the language from a couple sections ago, pivoting about this element. So the first thing we need is a 1 in that spot. So we'll do that by multiplying that row by 1/4. So that's going to give me 1, negative 1/2, 3/4, and then 1/4, 0, 0. Okay. The next thing we will deal with is the 8 and the 7. We need to change those into zeros. So we're going to do that using elementary row operation number 3. All right, and we'll do both of those in the same step. So first, let's fix row 2. So we're going to change row 2 by adding to it negative 8 times row 1. So let's go ahead and figure out what that is. We're not changing row 1. Still going to be 1, negative 1/2, 3/4, 1/4, 0, 0. Okay, but now we're ready for the new and improved row 2. So 8 plus negative 8 times 1 is 0. That was the whole point. Negative 3 plus negative 8 times negative 1/2 is negative 3 plus 4, which is 1. That's pretty lucky. 5 plus negative 8 times 3/4. Let's see, negative 8 times 3/4 is negative 6. 5 plus negative 6 is negative 1. Continuing on, 0 plus negative 8 times 1/4 is negative 2. 1 plus negative 8 times 0 is 1, and 0 plus negative 8 times 0 is 0. All right, so now let's do the same kind of thing to row 3. We're going to change row 3 by adding to it negative 7 times row 1. This is going to be a little uglier maybe. All right, so 7 plus negative 7 times 1 is 0. That was the whole point. Okay, negative 2 plus negative 7 times negative 1/2 is negative 2 plus 7/2. So let's think of that negative 2 as negative 4/2. Negative 4/2 plus 7/2 is 3/2. All right, that brings us here. 4 plus negative 7 times 3/4. You know what? I'm going to write that one down. 4 plus negative 7 times 3/4 is 4 minus 21/4. So we need to think of that 4 as 16/4. 16/4 minus 21/4 is negative 5/4. You have to be super careful with these fractions. 0 plus negative 7 times 1/4 is negative 7/4. 0 plus negative 7 times 0 is 0, and 1 plus negative 7 times 0 is 1. All right, so we are all done with the first column. Now let's clean up the second column. All right, so now we're ready to work on the second column. We lucked out again because the 2-2 entry here is already a 1. So that was just total luck. If it wasn't a 1, I would have to make it a 1. But since it's already a 1, I can go ahead and work on getting zeros in these two spots. So let's start with row 1. We're going to change row 1 by adding to it 1/2 times row 2. All right, so let's see what our new row 1 is. 1 plus 1/2 times 0 is still 1. Negative 1/2 plus 1/2 times 1 is 0. That was the whole point. 3/4 plus 1/2 times negative 1 is 3/4 minus 1/2, which is 3/4 minus 2/4. That's 1/4. 1/4 plus 1/2 times negative 2 is 1/4 minus 1, which is 1/4 minus 4/4, which is negative 3/4. 0 plus 1/2 times 1 is 1/2. And 0 plus 1/2 times 0 is 0. We're not changing row 2 in this step. But we are changing row 3. So the new row 3 is going to be obtained by taking row 3 and adding negative 3/2 times row 2. All right, so 0 plus negative 3/2 times 0 is 0. 3/2 plus negative 3/2 times 1 is 0. Negative 5/4 plus negative 3/2 times negative 1 is negative 5/4 plus 3/2, which is negative 5/4 plus 6/4, which is 1/4. Negative 7/4 plus negative 3/2 times negative 2 is negative 7/4 plus 3, which is negative 7/4 plus 12/4, which is 5/4. 0 plus negative 3/2 times 1 is negative 3/2. And 1 plus negative 3/2 times 0 is still 1. All right, we're getting there. So now we have to fix up column 3. We need to start by getting a 1 in this spot, and we're going to do that by multiplying row 3 by 4. So we like row 1 for now. And we like row 2 for now. Okay, but row 3 now is going to become 0, 0, 1, 5. And then negative 3/2 times 4 is negative 6. And 1 times 4 is 4. So now we're going to use that 1 to make zeros here and here. All right, so let's start with row 1. We need to get that 1/4 out of there. So we're going to change row 1 by adding to it negative 1/4 times row 3. So our new row 1 will be 1 plus negative 1/4 times 0 is 1. 0 plus negative 1/4 times 0 is 0. 1/4 plus negative 1/4 times 1 is 0. That was the whole point. All right, negative 3/4 plus negative 1/4 times 5 is negative 3/4 plus negative 5/4, which is negative 8/4, which is negative 2. That's nice. 1/2 plus negative 1/4 times negative 6 is 1/2 plus 6/4, which is 1/2 plus 3/2, which is 4/2 or 2. And 0 plus negative 1/4 times 4 is negative 1. All right, that takes care of row 1. And then row 2 is easy. All we have to do to get rid of that negative 1 is just add to row 2, row 3. Because when I add the negative 1 and the 1 together, that'll create my 0. 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. That was the whole point. Negative 2 plus 5 is 3. 1 plus negative 6 is negative 5. 0 plus 4 is 4. And I think we're all done, folks. 0, 0, 1, 5, negative 6, 4. Since we have an identity matrix on the left-hand side, that means the right-hand side is our inverse matrix. So the inverse of the 3 by 3 matrix that was given is negative 2, 2, negative 1, 3, negative 5, 4, and 5, negative 6, 4. Woohoo! All right. Let's go back to the presentation. I think there's just one more small thing to look at, but it's one of my favorite things. As soon as we check to see that this all looks familiar. And it does. That's the same answer we got. All right, so we're going to use matrix inversion to solve this system. 4x minus 2y plus 3z equals 0. 8x minus 3y plus 5z equals 1. 7x minus 2y plus 4z equals 2. And as a hint, I will ask, are you having deja vu? All right. And I'll give you another hint. Remember, we talked about how to use the inverse of a matrix to solve a system in the last section. In the last section, it was all 2 by 2, but that doesn't matter. Well, as soon as I switch over to the tablet, I think you'll see that this is actually a very easy problem, given what we've already done. So first you see I've written the system in matrix form. And hopefully this matrix looks familiar. It is exactly the matrix that we just found the inverse of in the very last example. So there is the system written as a matrix equation, AX equals B. And hopefully you remember from the last section that the way to solve a matrix equation like that is using X equals A inverse times B. And since we found the inverse in the last example, I've written it down right here. So all we have to do is just multiply these two matrices together, and we will have the solution of our matrix equation, which is the solution of our system. So remember how matrix multiplication works. Negative 2 times 0 plus 2 times 1 plus negative 1 times 2 is 0 plus 2 plus negative 2, which is 0. Next, we have 3 times 0 plus negative 5 times 1 plus 4 times 2, which is 0 plus negative 5 plus 8, which is 3. And then finally, 5 times 0 plus negative 6 times 1 plus 4 times 2, which is 0 plus negative 6 plus 8, which is 2. So there is the solution of that system of equations. XYZ is equal to 0, In other words, X is 0, Y is 3, and Z is 2. All right. And I believe that's going to do it for section 2.5. Here's the problem that you can use in the discussion for this module if you are one of my students. And to summarize, to calculate the inverse of a matrix by the Gauss-Jordan method, append an identity matrix to the right of the original matrix and perform pivots to reduce the original matrix to an identity matrix. The matrix on the right will then be the inverse of the original matrix. And here's a point that did not come up in any of our examples. If the original matrix cannot be reduced to an identity matrix, for example, you get an all 0 row on the left-hand side, then that means the original matrix does not have an inverse. That's going to do it for section 2.5, and that's going to do it for chapter 2. We'll see you next time.